All right. Working? Okay. Still working? All right. Okay. Okay. All right, guys. Thanks for coming. So today I'm going to talk about how to contain privileged processes, all those processes running as root, mitigate your risks for vulnerabilities. So essentially I'm going to talk about Linux hardening and all the ways that you can harden Linux. So before we start, I'm Parker Schmidt. Here's my Twitter, PJ Schmidt on Freenode. If you ever want to hit me up, I live in the Gen 2 Hardened channel. So just a disclaimer, I will be somewhat biased to Gen 2. I am a total fanboy, but I'm going to try to make this distro independent, but there's some things that are so much easier to implement in Gen 2, and so just a warning. So reason I'm giving this is a lot of people are not willing to harden their box. It's too hard. Even some distros, they'll put SElinux on the box. First thing everyone says is, just disable it. You Google SElinux, 50% of the results, it used to be even more, are how to disable it. And I'm trying to say, what I'm trying to talk about is why you shouldn't necessarily do that. You don't need to. And how this is going to become more and more important as time goes on. Because nowadays, when we look at a lot of malware, it is targeted, and you are going to start seeing 0 days coming out a lot more. People are going to drop them on you. So you're going to want to do everything you can. So I'm going to cover various mechanisms of Linux hardening, and then if there's time, because everyone's going to ask the question, did the NSA backdoor SElinux? And I'll try to answer that too at the very end, time permitting. So the main point is here, do you actually know what you are running on your system? You know how many million lines of code there is? I mean, did you actually notice Heartbleed? It was a pretty simple error, but no one actually noticed it for 2 years because no one has time to audit their entire system. I mean, no one in existence does. And you're going to always have vulnerabilities. It's going to happen. CVEs are always going to end up dropping. So a lot of people now, the technique is, okay, well, let's just check our processes that are outward facing, like our Apache servers, and just kind of have a shell over everything. But as we know, this doesn't work. And we've seen that demonstrated many times. So how do we fix this? Well, we almost want to go back to the basics of security. Least privilege. If you can't secure something, mitigate your risks. So that's what we're trying to do. We're going to try to go beyond Linux's discretionary access controls, move on to a mandatory access controls, increase memory protections, and actually enforce a lot of the standards that are just suggestions when you're making kernel modules. So before we begin, so I'm going to say a lot, mention user space and kernel space. Kernel space is essentially your mmap, mprotect, all your kernel processes, your drivers, and everything. And exploits here, I mean, all privilege escalation exploits generally will be in kernel, will end up going to kernel space. They'll be kernel exploits. User space is everything else, you know, everything on your system that you normally use. And oftentimes when you need privileges to talk to kernel space. That's why a lot of times for a while when you had a video card, you had to add yourself to the video group to actually use it on your desktop. So with access controls in Linux now, you have your user, your group, and the owner of the file. The owner can change the permissions. The owner of the file can chmod and root can chmod. And these are called discretionary access controls, which is as opposed to mandatory access controls. Now, if there's a formal definition, but really what it is, and kind of with the Father's Day theme, you know, if a kid says, well, Dad said didn't say I couldn't take a cookie from the cookie jar, well, that's the discretionary access. That's the way to think of discretionary. Thinking of mandatory is, well, I was never given explicit permission to take a cookie, so I can't take a cookie, and the kernel will prevent you from taking a cookie. So, what is SElinux? That's, by the way, an NSA data center. And it's not something you should just disable. I keep saying that. People do it, and they're wrong for doing it. So it'll set up mandatory access controls on your file system. And so every process has its own set of permissions. Not just this user can go here. It's this process is supposed to be doing this. So if it gets hijacked and it's supposed to go where it's not supposed to be, you're going to get a permission denied error. Even if you're root, you'll get a permission denied error. So user isn't all you need to do. And so, for example, Apache. it generally runs with high privileges. Actually, it used to run as root. We now all know, hey, this is a bad idea to run Apache as root, but it doesn't need to link into kernel modules. So if Apache is running with higher privileges and the Apache gets hijacked, there's a remote vulnerability, you won't be able to poke around too badly. Same with Samba. Samba doesn't need too much kernel access, but it needs PAM. So you give it access to PAM, you can still run it as root, but it's a whole lot less scary doing it this way. So SElinux, generally, there's three things: the role, the type, the user. Roles are what you're supposed to be doing. And users, there's actually generally 4 users, 3 in a strict system: user, staff, and sysadm, and then system is the kernel. So staff can escalate to sysadm when you're actually adminning the system, but generally, every process has its own user. Like if you're a VM, that VM is a user. So even if it's running with near root privileges, it's not actually running root privileges. And I will show a demo of this in just a little bit. I just, got to get, I'm sorry, this part is a little dry, but I just got to get through these things so I can show you guys. So targeted, that's what Red Hat does. Generally, if you want to harden your system, like put Firefox in a container, if there's a Java exploit, it'll still have the Firefox tag on that process. So it knows, hey, you shouldn't be reading someone's documents. You shouldn't be loading kernel module or trying to escalate to root, loading kernel modules. The system knows, hey, this came from Firefox. This is really just, this process should just be for web browsing. Strict is over the whole system, and MCS can essentially, what you want to use that for is for VMs. So each VM gets its own category, and MLS, I'm not going to talk about too much, that was invented by the NSA for classified stuff to say, hey, top secret, secret, and confidential has a different level. You're never going to use it. This is why you don't need to disable it. This slide, if you're going to learn anything about SElinux today, this is what you want to look at. So -Z is your friend. Everything, so ls-l, looking at the privileges, ls-z will show you the SElinux privileges. So pretty much anything you already know about Linux, if you push -z, that is your friend for SElinux. And I'll tweet out a picture of this and ask questions about that, but generally, if you are going to disable SElinux, check your SEVools. A lot of times, I have seen all over the internet, hey, Apache won't work with mod proxy with SElinux. So in the documentation, actually this was for the Atlassian tools, it said, we recommend you disable SElinux. Now that's incredibly stupid, because if you look at get SEBool-a, it'll list the booleans, and right there it'll say HTTPD proxy. All you do is set SEBool p, the bool name, on, or 1. And then it'll all of a sudden work. Just one simple command. And you're sacrificing all your SElinux protections. Now, to make this even worse, lots of processes are running as root, because a distro that has SElinux included is expecting that it is running. So they're thinking, I'm running as root, but it's not really root. There's actually some guy who had an SElinux system, and he had a t-shirt with his root username and password and SSH on, and he didn't care, because he locked root down so much that there was no issue. And the other thing, audit to allow. That is another one of your friends. You can turn your logs into a policy, all your permission denieds. And look through the policy too, because somebody will say, hey, if you fix this Boolean, it'll work. All your problems go away. So what I'm trying to say here is it's not really that hard. And here's just a list of of a bunch of websites that I looked. And this is part of my rant about don't disable it. People who say, hey, you should turn it off. Right there, how to turn off SElinux, not how to diagnose your problems and actually use this stuff. So, time for a demo. And I do have a video backups, demo gods, so don't be mean to me, etc. All right, so this one is running SElinux in targeted mode. All right, so, but you're right now, so ID, ID tells you where you are. ID-Z. You're unconfined. If you want to dump etc shadow, I haven't put any secure passwords, don't get your hopes up. It'll work, because you're in targeted. Oh, sorry, not root. My bad. It'll work. So, This is a known CVE. I'm just going to show this is going to work. But when you're exploiting a hardened system, you also want to check, but hey, I'm unconfined. That's great. So the reason I call this the good and the bad is because I'm first going to show the good. We're going to stop this exploit from actually happening. But then we're going to talk about how Red Hat configured SElinux wrong and it's not protecting you as much as it should. Okay, sorry. Actually, yeah, I do want root. So I'm root, right? Everyone agree? I'm root. So one nice feature of SElinux. I don't need to be browsing at C Shadow. Oh, shit, it's disabled. My bad. Because I ran the exploit earlier, that's why. And so I will show that to you. I do have a video backup. Hate you, demo gods. I absolutely hate you. Fucking spice. All right, so we'll run the exploit. This one's going to work, and I have a video backup for the rest. See? Same exploit. It failed. Now, just with SElinux alone, don't get your hopes up. Remember what the title said? Attacking hardened systems? Well, how about we do that? Let's do that. So this one guy from the GR security team, which I'll talk about in a little bit, wanted to troll the SElinux people and say, hey, you have this runtime disable feature. Well, all right, and I got root. SElinux was actually working there, and I still got root. And the exploit's actually really simple. I will show you in just a sec. It's one line of code just to make that work. So, and I put a demotivational poster because they use runtime disable. SElinux is now actually disabled from the system. But it's still going to show that it's running. And so you have no indication that it stopped. Unless you had an IDS rule that was just checking and dumping at C Shadow, you're not going to know. Actually, you could make a good IDS with that. So, a really cool thing with SElinux. So, you guys know about LXC and OpenVZ? So, they're virtualization systems that share your kernel. So you actually get native virtualization. Like not near native, truly native speed. Problem is, there's an issue with LXC. Root in your VMs was root on your system because you can access the kernel. Just like in that exploit, the way it worked is it went into the perf events and it ended up, so of course at that point you're in kernel space. You can just pop whatever the hell you want as root in user space. Not an issue. But with LXC, or with MCS, what you can do is say, hey, with LXC, I want each of these in a container. So it has a virtualization user, a VM user, but it'll say VM user S0, S1, S2. So if you were able to break out, you're still VM1 or VM2. And so the kernel will know, hey, this is coming from a VM. It shouldn't be talking to the host. And then it can say, no. And I'll show you in a little, so there's a lot of other scary things with virtualization, with a lot of the para-virtualization drivers. What if there's a bug in one of them, especially with things like RDMA? What if there's a bug and you can actually start popping things? And if you're sharing an InfiniBand card or something, you got remote direct memory access. It's sometimes hard to air-gap all that stuff, but with this extra protection, yeah, you might be able to jump out of the VM, but now you also have to exploit SElinux. So you got to drop another exploit to get out. And back to the don't disable it, it's not that hard. So svert, there's a config file. Actually, with SElinux, it's enabled by default with libvirt. If you have SElinux in MCS mode, it'll just work, confining all your VMs. So there, again, there is absolutely no reason to disable this stuff. Now, this is why that demo worked. So don't And so, if you have a pre-built kernel, don't do a pre-built kernel. Build your own kernels. Real people build their own kernels. And in addition, you'll be able, when I talk about packs, you will have to do this too. Just this one line. SElinux enabled, look up SElinux enforcing. Now I know the memory address of the Boolean that actually tells the kernel, hey, this is disabled. If your kernel supports runtime disable, well, guess what? I can just set that to 0. And that's what happened. And the place where SE status reads, it doesn't read from that Boolean. So guess what? I just disabled SElinux, and you don't know. So sometimes you say, hey, let's have that feature for convenience. Oh, someone would have to run some kick-ass exploit to break this, to disable SElinux too. Well, that's what you're trying to protect against, that kick-ass exploit. So it's really stupid to have that feature turned on unless you're actually in a dev box or something. And back to don't disable it, permissive mode. You can use it as an IDS. Also, you don't have to relabel your file system when you use permissive mode. It's a great way to learn. Copy your logs, use audit to allow. So, as we know, SElinux is not enough. And this is where the real security happens. This is a thing called PAX, which is from the GR security project. And they do have an RBAC system. We'll talk about that a little later. But this is a whole bunch of memory protections and enforcing the standards of kernel programming, like where you should have write permissions in your kernel module. And this will actually enforce them. And I'm going to make a point here, because a lot of times people say something will break on a hardened box. If something's not going to work on a hardened box, chances are it's vulnerable. And you got to do something about it. Sometimes you got to run something that's vulnerable. It's life. We deal with it every day. But chances are, if you're running it, if it doesn't work in hardened, it's vulnerable. And also with PAX, you're reducing the chances of remote code execution. You are increasing the chance of DOS. So, and for Gen 2, you can implement this really easily. Emerge hardened sources. There you go. You're done. Arch, you can do this too, and there's other distros, but I'm biased. Sorry. So, lots of PAX features. And I'm not just going to read through all of them, but ASLR becomes ridiculously better. You can sanitize your memory. Sanitize freed memory. Now, it's not going to stop use after free, but if you run a program, if you run a process if you run a process that has use after free on a system that sanitizes freed memory, well, that memory is sanitized, so it might crash. So if you're going to see something that's crashing on a PAX system, either sometimes you have to change some stuff, but generally, in most of the case, the app is messed up, not the hardening. Whoever coded it did something wrong, and there might be a vulnerability, and you got to check it out. There's various overflow protection to an insane degree. I mean, a lot of times we've seen a lot of implementations of ASLR in various operating systems, and everyone's finding issues with these. PAX actually does a ridiculously good job, but so much of a good job that there have been people who found a lot of DOS exploits in the kernel because you can easily crash stuff because it randomizes things too much. But generally, things are pretty stable. So you might run into some issues. PAX actually has some mitigation with trampolines. I go into that. But this is one feature. So if you are going to actually implement PAX, and I hope you guys actually will think about hardening a Linux box, and that's why you're here, and are curious about going through this, and might want to give it a try. Anyone who does want to give this a try, I'm on Twitter, I'm on IRC, love to help. This feature, though, ruined my day once. I was setting up a hypervisor on a hardened system. I thought, I'm not going to do the auto configuration of PAX in the kernel. I got this. I had that option enabled. I booted the VM. I was like, geez, this is slow. I went to lunch. OpenRC had just barely started loading. So when they give a warning saying there's a huge slowdown, they mean a ridiculously huge slowdown. So don't enable this feature. And because I'm just warning you guys. And you're going to have to bootstrap some processes, or your bootstrap Java. You're going to have to build stuff from source generally. It's just, that's life in this world with PAX. But I think it's worth it. And actually, PAX will stop that CVE. And we don't have time for that demo today. I had to cut one, but I will tweet that out to show it failing. But I mean, failing exploits is a lot more boring than when they actually work. So other things, GPU drivers. If you're running a non-Gen 2 distro and want to do this, because you're probably a masochist and don't want to use Gen 2 and are obsessed with not using it, then look at the header files. the header files you can actually tweak, and if we have time, I will actually show you how to tweak those. But you just change the way KMEM is called in the header file of the NVIDIA and AMD drivers, and they actually work. And some guy actually figured that out because they were running Hardened on their laptop. I'm not. I do it for servers. This hardware is not ready yet. I might put SElinux for Firefox, but to be honest, you're not going to need to use the GPU too much and so that other stuff. So on your servers, you'll not run into any problems with this. So the third one, GR security, and that contains the PAX project. So what they've essentially got is they've got a lot of features that look for PAX alerts. When PAX kills something, it'll take response. And it also has a MAC system. I actually like it better than SElinux, but there's one reason I focused on SElinux. So with GRSec, the problem is there's no policies. You can't load, that .pp file, you can't load those. So the only way to do it is put it in learning mode. Now, we all know the downside of this is learning mode. Well, what if you're actively being exploited? And also, in a dev environment, you're not actually simulating what's really going on, what your users will actually do. So you might run into problems. But besides that, if you disable the RBAC system on there, it's still some fantastic security protections. And I hope people put more into this project because I do think it will end up doing better than SElinux someday. So this is one of my favorites. And the reason I have the self-destruct button, because just how, and I'm actually scared to implement this one, but if PAX gives an alert, and there's generally, the time you'd see this is there's ASLRs going, right? And so with the buffer overflow exploit, if you have ASLR and there's no info leak, you just keep running it. Well, not here. You can't keep running it because PAX will say, hey, you crashed the program. Hey, this program keeps crashing. Well, okay, there's something going on. If it's not root, I'm killing that program. It's not going to run anymore. I don't care if your server's down. I think someone's exploiting it. If it's a root, it's going to panic the system. And honestly, if you're really that concerned about security, if you think someone might be rooting your box, you want that system to die. I'd rather take downtime over some random guy rooting my box. Because chances are, once they get it, they're not going to be very nice. Because I know if I'm rooting someone's box, just to prank them, we're never nice to each other when we're pranking each other and rooting each other's stuff. So, could only imagine what the underground is doing, and we all know. So, that can get. Can deter brute forcing. If you're brute forcing an exploit, there's the same kind of thing, when you're trying to deter brute force logons. If they log on wrong too many times, you make them wait. Same thing here. You're running an exploit. Hey, this keeps dying. Well, let's make it wait 15 minutes before this process runs. And if it's an SUID, SGID binary, let's be stricter, because that is actually really sensitive. And same if you're exploiting a race condition. If you end up triggering something, because a lot of times you're exploiting a race condition, sometimes you're just trying to hit it tens of thousands of times. And this can actually catch it. Now, this stuff is not guaranteed to catch all the exploits, but if you're an attacker, your life's going to be absolutely miserable at this point. Are we kind of all agreed there? Your life's getting really miserable. If you've done CTFs, you're seeing why this can really, really suck. And so other features, put root hardening at the top because someone here will remain nameless has a BSD tattoo. Yeah, okay, back there, SOB. And so, got to troll them a little. So we have jails too, because I know BSD people say, hey, your root suck. Well, they now suck less. So Linux has one more point there. And you can do stuff like disable privileged I/O, restrict some module loading, restrict that to root. The USB protections, I'm not too worried about, because honestly, are you really going to allow USB mass storage in your data center? I'm not. I mean, yeah, you might need it, but it's really easy to just put a USB drive somewhere and no one will ever notice it, especially if it has a 4G card. So, but yeah, just disable that. You don't really need it. Now, another concept, hardened GCC. So I said, why not? So the idea is why not make the exploits never possible, and get rid of the vulnerabilities altogether. And I said, well, we're not going to audit code and fix it. So what do you mean by this? Well, let's have the compiler fix the problems for us. And again, here, you're going to want a source distro. And I'll talk about this a little later, because if you're generally building binaries and have statically linked binaries, you will run into some issues with this. Some distros are putting a few features of this in, they're not quite there yet. Here are the 4 major features, and the top 2 are what really matter. SSP, which is a stack smashing protector. They put in stack canaries. Now, if any of you guys tried to exploit a buffer overflow with canaries, it sucks. We're all agreed here, it really sucks. And so you have fewer bytes to write your shell code. It's really not going to be fun. And Pi makes it so this makes ASLR have such a good time with your processes. Because PAX knows, hey, an executable is position independent. So I can go all ASLR all over everything, and so you don't need to have such a half-assed ASLR that you're seeing with stuff on Windows. How many tweets have we seen about Windows' ASLR being broken? I think I've seen like 20 in the last 2 weeks about that. We have relrow, which is when sometimes you need write permissions when a binary is loading. I'm not going to go too into this, but it doesn't need to write when it's running. And bind now essentially makes it so things with relrow don't take forever to load. So it's essentially, let's harden it. Hardening kills performance. So let's do something that fixes the performance and makes it go faster so no one notices the difference, was what the bind now is. And a warning about Pi. So if you're doing a binary distro, if you're adding binaries and you're not building from source, you might have a couple issues. You can always turn off Pi. And in Gentoo, it's really, really easy. All you do is you change the profile. eSelect profile list. Actually, screw it. I will show you. This VM's not even done yet, this one, because I'm working on a new template here. So I'll just cheroot into it. This is a brand new, I've just unpacked stage 3 on this. Well, I'll have it loading up while I do this. Because I just want to show you how ridiculously easy it is to implement this and why everyone should do it. And honestly, if I were to make a security standard, I would require it. But maybe I'm just mean. And so, now, I've promised you guys this is not a total blue team talk. And so, we know hardening's getting more popular. And, this phone's got SElinux on there. It's in enforcing mode. And I was an idiot and forgot to pull out the battery when AT&T was pushing an update. My bootloader's locked. I still regret that day. But even phones have SElinux now. So we actually have to start thinking about it. We have to, I know at first we're kind of lazy and thinking, okay, well let's just hit the systems that are not hardened and not worry as much about the hardening one, because it is a lot more work. But nowadays, that's going to change. You're going to see this more and more. So here's what we've got going right now. SElinux. So the way you have to change your thinking is root's not always root. If I get root but I don't have any privileges, I'm not root. Generally you can't dump at C shadow. If you have root. Various other things. If you're user-u, you can't edit any of the config files. PAX, you got really crazy ASLR, a grsec. You can DOS the system really easily. If you're anonymous, hey, this is great. They'll probably love hardened systems, especially when people find more issues with PAX and ways to exploit it. I don't think there are right now, but if there are, people that like to DOS will love it. It actually helps them. But right now, if you're an actual attacker, isn't the goal to be quiet? Don't you want to be as quiet as you can? So DOSing the system would really, really suck. So, and hardened GCC reduces your arsenal. So the idea here, if you have an exploit, this is assuming you got a working O-Day, you're ready to go. If you're going to escalate and you can't disable SElinux from that, escalate as the right user. If you can stay as sysadm, so there's 2 different ways you set your ordinary users. User and staff, and sysadm. Sysadm is, hey, I'm logged in as root, and I'm administering the system. I need root privileges. I need to escalate to do kernel stuff. So you essentially have run init, which is a sudo that does that. But that's all out there. So when you're implementing SElinux, you'll be warned about how to handle all of that. But if you escalate as an ordinary user of the box that doesn't do any administration, you're not going to be able to raise yourself to staff. Other thing, phishing passwords will be a better way, because an SSH key is not going to be good enough. Because usually you have it so if there's a sysadmin user and they're in the staff role, well, they get staff when they go in there. So yeah, you have the SSH key. You're right in there. But you need the password to go up to sysadm, so you're going to be extremely limited. Instead of who am I when you're exploiting, ID-Z will tell you. And so you want to be in the right place, in the right role to exploit. And the other thing, if you're in kernel space, kill it. And so this is how we do that. Those 2 lines. That's all you need to disable SElinux. And the thing is, if you can't disable it, so let's say you get rid of runtime disable. And this is the fatal flaw of SElinux. And it actually really pisses me off, and I think it needs to get fixed, is you can, there's a command, set enforce 0, set enforce 1. When you're setting up an SElinux system, it's awesome because you temporarily turn it off. But there's no way to disable it. So I just go, okay, fine, I'll change that exploit, I'll comment out that line, SElinux enabled. Still have SElinux enforcing. I know the Boolean. It's an int pointer. I just will go star SElinux enforcing equals 0. Okay, now I win. That exploit that stopped, it works now. With tax, life sucks. Move on. Okay, we're done. Let's just get out of here. No. In all seriousness, your life is going to suck. But not all your exploits are actually going to work. It's just what you're going to have to deal with. And when you run an exploit, it's dangerous. You could end up panicking the system if they've got the active exploit response enabled. Now you're no longer stealth anymore. No one actually, you're not hiding. They know they're under attack. Look at the target breach. They were slow as hell. They were getting everything out slowly but surely. You got to be patient. If you're going to end up DOSing a system, it's not going to work as well. Yeah, they were ignoring their FireEye warnings, which I found kind of hilarious. But if a server actually was getting DOS or actually started panicking, it might cause more alarm, hopefully. But I've lost a lot of faith in many people doing many routines out there. A lot of corporate entities who, if you are ignoring your FireEye alerts, maybe you won't miss that a server's been down for a week, unless it's a customer-facing one. And then your customers might bring it to your attention. So if you want a DOS, PAX is nice. Run your exploits. Fuzz stuff. Fuzz the crap out of it. But honestly, DOSing is not, you're not going to get as much out of it, unless you're just some activist group. But that's not what people are as afraid of, because you can always just bring a server back up. And here's the other point. Don't escalate. If you can do stuff, I know it's a lot easier when you root a server. Don't root it. You can do a lot without privileges. And try to do it without root privileges. Because if you're going to run something, look at the active exploit response, what the description said. Would you rather have a process get killed, or would you rather panic your victim's system? It's kind of an obvious choice. So, grsec, all those features, don't always run your exploits. Be more crafty. Hit the desktops. If you're trying to go into an environment that's running hardened Linux on the servers, the desktops are still really soft. Chances are someone from the desktop's going to log in, so follow them in. You can always fish. We know this. You can always pop any desktop you want for probably, well, maybe all of eternity with things like set. Because, I'd even click run on that thing. So, only run them if you need to. And RS-back system, same thing. Find out who you want to be if you're going to escalate. And the other thing to do, if they're deploying a new server, doing some updates, they're going to run the learning mode if they're doing the RBAC system. And so, since it's in learning mode, you might be able to exploit it because, hey, it's in learning mode. I'm not actually doing protections. And guess what? The learning mode will learn your bad behavior, and it'll be okay forever. So they might not notice it for a long time. And this is what you are not safe from. So the reason I put Heartbleed there is, yeah, you had ASLR. On a PAX system, Heartbleed still works. That's, still everyone's talking about it because it was ridiculously scary. And so my point is, stuff in user space, stupid stuff you do in user space will still be there. These mechanisms are mainly for kernel space. Yeah, generally you have to do everything talks to the kernel because you can replace an entire user space. I mean, have any of you guys actually on a server you're going to trash tried running rm-rf/ and know what happens? A lot of stuff still runs. It's kind of crazy. It still actually is running. Okay, you're nodding over there. So you've done it. Okay. I think I'm going to give you a ticket for that. Since you're acknowledging that you have rm-rf/ to box.
Yeah, Frank said, hit that key.
And the guy in the MacBook too. Right, or you were, okay. I see you got that first. I got another question that will get the last ticket. So, you're not going to be protected from stupid shit developers do. And if you're a developer like I write stuff, we're going to make mistakes, and still you got to write better code. Everyone does, and that doesn't go away. This is going to try to mitigate disaster, but disaster can still happen. The real reason ASLR didn't stop something like Heartbleed is it's reading directly from a buffer. When you're entering that, Heartbleed would read that buffer. Even if there's a randomization, the kernel module would do the memory mapping, and then it would just see the array, and it would spit back the array in user space. So there's no way any ASLR could have stopped something like that. So I know that could be an easy misconception. Okay. I guess I do have a little bit of time to talk about this, and I'm going to leave 5 minutes for questions at the end. But people always troll when you're talking about SElinux saying, hey, there's a back door in there. And after Snowden, well, people are getting kind of pissed at the NSA. I mean, I actually had my concerns. So I went and did some Googling just to see what's going on. Because it seems like the NSA, at some periods of time, just like when NIST had the contest for AES, they seemed to like to say, hey, we're going to give money to smart mathematicians who find ways to secure this country, because if we know something, so does the KGB, or so do any other countries. But it's interesting, though. I looked at the NSA's documentation. It stops in 2009. And it seemed like there was, in previous regimes, they started a spying program, and as we know in recent years, it was escalated a lot. So this is just me guessing. I don't know. I don't know any of this, but if they are going to stop something in 2009, it would seem to me that this would be something that's not backdoored. It's also an open source project. They've not developed too much since 2009. People probably would have seen something. People have poked around. It's an open source project. They know people are going to poke around. They're not going to risk it. So I don't think it is backdoored, actually. And so that is my guess. I can either do questions, or I can show some of the code from the exploit and show how you can get Pax to work with the video driver. Do you guys have questions, first of all? Let's just go that way. And then I might show some stuff if we don't. It's just, all I'm doing is just showing it in the text editor, like this is how you do the disabling SElinux. I showed those lines of code. Those lines have already been in the talk. So, any questions? Let's just do that first, because we have, how much time do we have left? 7 minutes? Yeah. Yep. Yeah? So a lot of times what I do, and it's, Google is your friend as it is always. So Google, whatever process this is, and SElinux. The other thing too is get SEbool-A. That is your friend. Actually, I will show that to you. I'll do it. I'm not totally Gentoo biased. I'm showing you on a Red Hat system, or on a CentOS, because I'm not buying Red Hat. Why would I actually pay for something that I hate? But actually, SElinux is disabled on this, so I'm not gonna fuck with that one. I'll do it in targeted mode. So, and so you can look up the booleans. So look at this. This is pretty much all the stuff you would need. Hey, if you want NFS to use home directories, a lot of people would say, oh, disable SElinux with NFS. No, all you would do is set SEbool-P. whatever you wanted to do. So let's just pick a different one because I don't feel like scrolling up and looking for it. X server. Type today. All right. Oh, sorry. I don't have an X server enabled, so maybe that was not the best one to use. Oh, no. What's something else? Because this is all the Booleans. Oh, it's secure mode, so I'll just show you. See, that's all you would do, and it would do that. It might not be working because I was poking at these systems quite a bit earlier, running a whole bunch of exploits. But generally, you just get SEbool-A, and you see all that stuff. And I mean, do these actually make sense when you can see all this? And pretty much anything you need to do. I mean, can network connect? That's why people are disabling SElinux because you can't connect to the Apache server. Well, no, you just got to turn it on. Generally, when you turn things on, they work. Cameron. All right. Audit to allow. Sorry. So in Gen 2, it's called abc.log. Here, I think it's audit.log. But what you do is, what you do is you go to the ABC logs or the audit logs, and you end up looking at it and go audit to allow -I, the name of the log, -O, proposed policy.pp, or whatever you want, .pp. And that's an SElinux policy source code file. And then you can compile it into an SElinux policy. So you can actually automatically generate the policies. And I would suggest reading through it, because sometimes it'll say, hey, there's an SEbool you should just enable and it'll work. So look through them. But yeah, you can automatically generate your own SElinux policies. And a lot of times, if there's an issue and you're not seeing errors, disable, don't audit. You can see that on Google. Because I was having some issues with MCS and libvirt, because we were trying to get that working for Gen 2 about 4 years ago on the Hardened team. And so I had seen some issues, and I disabled don't audit, and a bunch of stuff started coming. Because don't audit, you can put stuff in there for the operating system to say, hey, we're going to get errors here, but it's not an issue. Something's just panicking, and we just don't want to really deal with that right now. And so they can kind of suppress that, so you might want to disable that. Other questions? Yep.
How often do you find hardened systems in the wild versus actual systems that actually have protection in corporate structure and stuff like that?
So the troll answer to the question is, well, as of last year, everywhere, because you got mobile phones and Android. But to be honest, a lot of people are disabling SElinux. And here's why I really don't like that. So I'm just going to run PSOX. This is my desktop. How much stuff this is all kernel processes, but look at how much stuff is running as root. If you're not using a mandatory access control system, you're running stuff as root, which everyone knows we shouldn't do, but we do it anyway because a lot of times it's a huge pain not to. But no, vanilla Red Hat systems, you'll see some hardening. And but no, not very much, to be honest. And I'm trying to get people to start using it more. And that's why we're doing this today. All right, we got 2 more minutes, I think, or 1 more minute. Yes. No, and it's an actual patch to the kernel, and yeah, that kind of sucks. And so, a friend of mine and I actually were working on one of the Gen 2 devs doing some hosting eventually. We don't have time right now, but in about a year or so, we're talking about maybe doing some Gen 2 hardened hosting for that reason. Because you're right, there isn't any when they give you a kernel, and it kind of sucks. You can still use SElinux, but the problem is one way you could do it, it might be against policy, might get you in trouble. If they allow kexec in their kernel, you could potentially, I don't know exactly your setup, if they give you a VM, but they restrict you to one kernel, you could try to replace the kernel, build a new one, and run kexec. You might get in trouble, but and with other distros, even if they don't have a kernel source with grsec, it's just a patch. So, well, there are questions? All right. How much time do I have left? All right, so I'm not running under then. All right. All right, no, I mean, I'm ready to go. I was just, once we're out of time, I just wanted to leave time for questions, and if it's time to go. If people have more questions, I'm willing to stay around. If not, we can meet outside and talk.